Okay guys, today we're going to look at sections 2 and 3 in Unit 9. In section 2, we'll be doing prime factorization. And in section 3, we're going to be doing rules for exponents. Okay, let's get started on section 2. It'll start on page 486. And we're going to look at the definition of a prime number. A prime number is a whole number. So if you remember when we studied our sets of whole numbers start with 0, 1, 2, 3, 4, and so on. So it's a whole number that has exactly 2 factors. 1 and itself. So when we think about our set of whole numbers, 2 is the first prime number because the only factors for 2 are 1 and 2. Then if a number is not a prime number, it is a composite number. And a composite number is a whole number that has more than 2 factors. That would be like 4. Because what goes into 4? 1 does, 2 does, and 4 does. More than 2 factors. Okay, our first example is going to be determining whether a number is prime or composite. So as we look at example 1, they want to know, is this number prime or composite? And our first one is 15, and then B part is 23. So when you're trying to decide if a number is prime or composite, then just think of everything that divides into it. So 1 goes into 15, 3, 5, 15, more than 2 factors, so this one is composite. So trying to decide on B part, 23, well the only numbers that go into 23 are 1 and 23. Only 2 factors. That makes this number prime. Alright, let's look at example 2. On example 2, they want us to do a prime factorization for 90. So when we do prime factorizations, that's the factor tree. I'm sure you remember doing this. So when you do a factor tree, you break it down into 2 factors. Doesn't matter which 2 you think of. I think of 9 and 10 when I'm thinking about 90. 9 and 10 both are composite, so I still need to keep going with my factor tree. So that's 3 times 3, and 10 is 2 times 5. That's a prime number, that's a prime number, prime number, prime number. So the prime factorization is 2 times 3 to the second times 5. And there's my final answer. So when you're doing a prime factorization, you keep breaking down the number until all you have left are prime numbers. When you write the prime factorization, you start with the smallest number first and then go in ascending order. If a factor appears more than once, then you represent that with the exponent. All right, example 3. On example 3, it just asks us to factor. And A has 11R to the 4th S. And on B part, we have negative 28 A squared B cubed. So 11 is prime. So when I break down 11, only 1 in itself will go into it. R to the 4th would be R times times R, and then S would just be times S. So that would be my factored form. On B part, 28 is composite. So when I think of 28, I think of 4 times 7. 4 is composite. That would be 2 times 2. So when I do the factoring, it's not a prime factorization. So when I do the factoring of this, I do need to represent the negative with a negative 1. Then I would have times 2, times 2, times 7, times A, times A, times B, times B, times B. So I'm breaking down what it takes to multiply to give me 28. The only reason I had a 1 in there is because of the negative. So final answer on this one would be negative 1 times, I can say 2 to the second, because the 2 times 2, times 7, times A, times A, times B, times B, times B. Okay, those are our 3 examples in this section. In this section, we're going to do the problems on page 488, 2 through 30 even. Make sure you write the problem. Okay, let's move on to section 3. In section 3, that's going to start on page 495. And we've got some rules for exponents. So we have the product rule. And the product rule says that if you have 2 bases that are the same and they're multiplying, then you add their exponents. So if I have a to the m times a to the n, if these are the same, then I add their exponents. And then we have the quotient. And the quotient rule says if you have 2 bases that are being divided and those bases are the same, a and a, then you're going to subtract your exponents. Okay, let's look at example 1. Example 1 on A part, I have 4 to the third times 4 to the fifth. I'm multiplying. Bases are the same. So the rule says I add the exponents. So then my final answer is 4 to the 8th power. I do not have to evaluate and find out what 4 to the 8th power is. That is my final answer. Direction C, to leave it as an exponent. On B part, I got 6 times 6 to the 4th. Both of these are 6's. So the rule says if bases are the same, I add the exponents. My question though is, what's the exponent here? If there's not an exponent, it's understood to be 1. So I would say 6, 1 plus 4, and my final answer would be 6 to the 5th power. So when you're multiplying bases that are the same, add exponents. Example 2. I got, instead of numbers, I have variables. I have b to the second times b to the second. They're both b's, so my rule says keep the base the same, add the exponents, and that's b to the 4th for a final answer. It's real easy to see because we just got through doing a section where we had to write out what bases and exponents meant. So b to the second is b times b, and then this would be b times b, and then we can easily see why that's b to the 4th. On part B, we have 2x to the third times 8x to the fourth. So the bases here are the x's. So I'm actually going to multiply the 2 and the 8, and that'll be a 16. And then I add the exponents of 3 and 4. So then my final answer is 16x to the 7th. So the 2 and the 8, they were not same bases. So we didn't use the rule on those. The bases that were the same were the x's. So that's the one where we use the rule. All right, example 3, we're going to use our quotient rule. On A part, we have 8 to the 5th divided by 8 to the third. When bases are the same, and they're both 8s, we keep the base the same and we subtract exponents. So that would be 8 to the second. And that's the answer they want. They don't want to know what 8 to the second is. Just keep your base the same and do the subtraction. On B part, using variables, but same rule, we got c to the 7th over c to the second. Both of these are c's. So since the bases are the same, I keep the base and I subtract the exponents. So 7 minus 2 would make that c to the 5th power. And that's my final answer. Okay, only 3 examples in that one. Refer back to your examples when you're doing your homework. And in this section, it's going to be on page 497. We'll do 2 through 24 even. And again, make sure you write your problem. Email me if you have any questions. Okay, so for this assignment, we'll be doing lesson 2 and lesson 3. Evens on the first lesson on page 488, 2 through 30 even, and on page 497, 2 through 24 even. Okay guys, I look forward to seeing your emails.